Okay, so in today's video, we're going to cover dividing monomials, dividing polynomials by a monomial, which is at the bottom of page 6 in your packet. Now, before we jump into this, let's talk about a couple of little housekeeping things I need you guys to take care of, and some communication stuff. So first of all, if you're not checking your emails daily, and if you're not checking the stream in Google Classroom daily, you need to make sure you do that. So every day, click on the stream, check your email, make sure you're keeping up with communication. And I know you're getting a lot of stuff from me right now, so that can be stressful. It might help if you once you've checked emails from me, if you put them into a folder on your Google or your Gmail, and you can learn how to do that, and that'll kind of help filter it out and keep it a little bit cleaner. Okay. Secondly, if you have not filled in the Google form about packet pickups, you need to do that. That's posted on the stream in Google Classroom. And if you don't have your packet yet, I did put a PDF copy on the materials part under classwork, so you can use that to access it and write down the problems. You can also print from there. And the third thing is, I also posted on the stream today a checklist of all of the things you should have accomplished or should have completed by the end of our 2 weeks of virtual that we've done since the beginning of the semester. And I broke it out into not just assignment for this day and that day, but watch the video, complete the Delta math, etc. So go through and you'll just have to make a copy of that Google Sheet. I won't see it, but it's something that you can use if you want to take a look and say, okay, yes, I've completed everything I should have, or you can go through and be like, oh, I don't know if I've done that, or you can check and see, okay, I watched the video, I took the notes, but I didn't do the Delta math yet. So make sure you're keeping an eye on that kind of stuff. Finally, Google Meets. I have not had great attendance on Google Meets here of late. I would love to see and hear more of you guys. If you have not been able to attend the Google Meets at the set times, but you feel like you need some extra help, please email me to set up a meet, and I will work around your schedule. I have some free time that I can work around, so just let me know. Okay, so now let's get into the math. Dividing polynomials by a monomial. So what happens when I zoom out and can't see my thing. So the directions on this are a little bit meh. It says divide each term in the numerator by a monomial in the denominator. And then write your answers in standard form. Rewrite all terms with negative exponents. So basically, we're going to do these 6 problems together today. I did not give you a Delta math on this one. I'm kind of giving you guys a bit of a break. But we're just going to go through these 6 problems, and I'm going to show you guys what it really means when they talk about dividing each term in the numerator by the monomial in the denominator, and how to write it properly. So problem 1 says 9m to the third minus 24m squared over 3m. So 3m is our monomial on the bottom, and 9m to the third is the binomial on the top. So since it's a binomial, we're basically going to set it into 2 separate fractions. So we've got 9m to the third divided by 3m, and 24m squared divided by 3m. And I put a minus in between because there was a minus up here. Let me erase that string mark. Okay, so now how do you divide it? 9 over 3 are coefficients, or big numbers. So you're just going to divide those out like you would if I gave you 9 divided by 3 as just the only problem. So 9 over 3 becomes 3. For the m's, we're going to apply what's called the quotient rule. So if you remember from last week, that means we subtract the exponents. What is 3 minus 1? And we're going to write that as m squared. Okay? Then we're going to look at the second fraction. So we have 24 divided by 3, which is 8. M squared divided by m, so that's going to be 2 minus 1, which is just m. And I'm going to go ahead and circle that as my final answer because now I have 2 things that are not alike, and I can't simplify it any further. I also don't have any negative exponents, so I'm good. Okay, now let's look at the next one. The next one says 20x to the third minus 4x squared minus 8x over 4x. So we have a trinomial, or 3 terms on the top. So we're going to set up 3 fractions this time to solve. So we have 20x to the third over 4x minus 4x squared over 4x minus 8x over 4x. And then we're going to divide everything out. So 20 divided by 4 is 5. For the x's, you've got 3 minus 1, which gives you x squared. Okay, put a minus sign because they had a minus sign up there. Now we look at the next one. 4 divided by 4 is 1. X squared minus x, so it would just be x. Now this one, you can write the 1, but since it's an understood one, we usually get rid of that. Or we just call it minus 1x, we call it minus x. On the last one, you have 8 divided by 4, which is 2. And then x divided by x cancels out, so you would have no letter on that one, so it would just be 5x squared minus x minus 2 for that last term. And I will tell you that if you didn't have any like terms in the numerator to start with, you will not have any like terms in your final answer. If you started off with a trinomial or 3 terms on the top, you're going to have 3 terms in your final answer. If you start out with 2 terms on the top, you're going to have 2 terms in your final answer. Once you divided all the fractions out, nothing is going to combine any further. Okay, so number 15 is a division problem. It just doesn't look like it. So number 15, it says this whole thing, this is your numerator, 14a to the 4th b to the 3rd minus 20a squared b squared plus 2ab. That's your entire numerator. And then this right here, because it's a negative exponent, that becomes your denominator. So it's all of these things divided by 2ab. This negative exponent means that's what you're dividing by. So you're going to set it up like this. 14a to the 4th, b to the 3rd over 2ab minus 20a squared b squared over 2ab, and then plus 2ab over 2ab. So now we're going to simplify. 14 divided by 2 is 7. For the a's, you do 4 minus 1, which is a to the 3rd. For the b's, you do 3 minus 1, which is b squared. Then we go to the next one. 20 divided by 2 is 10. For the a's, you've got 2 minus 1, which is just a. For the b's, you've got 2 minus 1 again, which is just b. Okay, then we look at the last one, and it's 2ab over 2ab. So this time, since we're taking something and dividing it by itself, we're going to replace the entire thing with the 1. And because it is a number with no letter, we do have to write the 1 here, unlike the one above, where we could get rid of the 1. This time we do need to write the plus 1 there to indicate that the entire thing divided out and we're left with 1. Okay. One thing is, if you have 2 letters, you consider each one separately. So you figure out what happens with the A's, what happens with the B's. All right, now let's look at number 16. 16 is an example where the fractions don't simplify completely. I am going to zoom in a little bit on this one. Okay, so 16 says 30c8d3 minus 36c to the 6d squared plus 6c to the 3rd d, all divided by 12c squared d. So we've got 30c to the 8th d to the 3rd, or 12c squared d, minus 36c to the 6th d squared over 12c squared d, plus 6c to the 3rd d, or 12c squared d. So now I look at these fractions. 30 does not divide evenly by 12, okay? It comes out as a decimal. But I can simplify the fraction 30 over 12, and it reduces to 5 over 2, because I can divide them both by 6. So that's what I'm going to write is 5 over 2. And then I'm going to simplify the letters. So for C's, I've got 8 minus 2, which is C to the 6th. For the D's, I've got 3 minus 1, which is D squared. Then I'm going to look at the next one. 36 divided by 12. This does divide. It comes out to be 3. For the C's, I've got 6 minus 2, which gives me C to the 4th. For the D's, I've got 2 minus 1, which gives me just D. And then for the last problem, 6 over 12 does not divide out evenly, but I can reduce it to 1/2. Then I look at the c's, and I've got 3 minus 2, which becomes c to the 1. And then the d's cancel out completely because it's 1 minus 1, which makes that term go away. So I have 5c6d squared over 2 minus 3c to the 4th d minus 1c over 2. You could also write this last one as just c over 2 if you wanted to. Okay. Question 17 is going to show us what happens when you get negative exponents and how do you write that. So 17 and 18 are both going to address that. So in 17 we have 30x to the third minus 12x squared plus 9x on the top. And then we have 3x squared on the bottom. So again, we're going to split this one up into 3 fractions. So I've got 30x to the third over 3x squared minus 12x squared over 3x squared, and then plus 9x over 3x squared. Now I'm going to simplify by dividing everything out and using my quotient rule. So for the first one, 30 divided by 3 is 10. For the x's, I've got 3 minus 2, which is just x. For the next problem, 12 divided by 3 is 4. X squared divided by x squared, that's 2 minus 2, which is 0 and cancels out. So that means we have no x. For the last one, you have 9 divided by 3, which is 3. And then for the x's, you have 1 minus 2, which gives you x to the negative 1. And when you subtract, you always subtract numerator minus denominator. So now we do have a negative exponent. We need to clean this up. So to rewrite it completely as the final answer, you're going to write 10x minus. So we have 10x minus 4. Sorry, my microphone turned off there for a second. And then plus 3 over x. Okay, so it becomes 3 over x because x to the minus 1 was unhappy, and so we needed to move it down. Then none of these combine, okay, because this is 10x, this has an x, this is just a number, this has a fraction. Our answer on this one is actually not a polynomial, which happens sometimes when you divide. So that's okay. All right, number 18, last one. Let's look at this one. It says 40m to the third n to the fourth minus 24m squared n to the seventh over 8m squared n to the fifth. So here we have a binomial on top, so we're going to set up 2 fractions this time. So you've got 40m to the third n to the fourth over 8m squared n to the fifth. Put a minus because you had a negative here. 24m squared n to the seventh over 8m squared n to the fifth. So we're going to start simplifying. Start with the numbers. What's 40 divided by 8? And that's 5. For the m's, you got 3 minus 2, which is just m to the 1. For the n's, you got 4 minus 5, which makes it n to the negative 1. Okay, then we're going to look at the second fraction. We're going to simplify that. So you're going to put a minus in between because that's what you had to begin with. For the numbers, you have 24 minus 8, which is 3. For the m's, you've got 2 minus 2, which is m to the 0, so that cancels out. Anytime you have the exact same thing top and bottom, like m squared over m squared or x over x, that term is going to cancel out completely. That letter is going to go away. And then for the n's, you've got 7 minus 5, so it becomes n squared. Then for the last bit of housekeeping, this needs to move to the bottom, so you're going to put 5m over n minus 3n squared. Okay, so record these problems, fill in the Google form that's just going to ask you a couple quick questions, and then email me if you have any difficulties. All right, have a good afternoon.